This is part 3 of analyzing the first derivative. In this video I'm going to analyze the graph of a first derivative. So the first example says that there's a graph of a first derivative shown. So you should copy this graph into your notes, make it dotted, just like the other derivatives, just to keep everything consistent. So this is, keep in mind this is the graph of the first derivative. Part A is asking on what intervals is it increasing. And we have to just rely upon the definition. In order for something to increase, a function to increase, the derivative has to be positive. So I'm looking for aspects of this graph where it's positive. Positive meaning it's above the x-axis. So it's positive from -1 until 3. At 3 it's going to equal 0, and 0 is neither positive nor negative. So I have to kind of skip over 3, and then from 3 to infinity. So again, it's going to be positive, it's going to be increasing when you have -1 to 3. That's this portion of it. And then I have to skip over 3. And then after 3, it's going to be positive again, all the way to infinity. Part B, on what interval would the function be decreasing? Again, based on the definition, if the derivative is ever negative, you'll have a decreasing function. So I'm looking for where this is below the x-axis, which is from -infinity to -1. So I can put my answer as x is an element of anything that's from -infinity to -1. Part C, find the x value at which f would have a relative minimum. Then I have to justify or explain my answer. Based on the first derivative test, a minimum is going to occur whenever the derivative changes from negative to positive. So I'm looking for where this graph has a negative to positive sign change, and that's going to be at -1. And the way I justify it, I just have to kind of restate the first derivative test. I can say that the f prime, the derivative, changes from negative to positive at that point. So from negative to positive at x is equal to -1. And to just kind of confirm our answers, I have the graph of the derivative along with the function. And you can see that it's increasing from -1 until 3. So this graph is going up. Right at 3 it doesn't increase nor decrease because the derivative is 0. Then after 3 it begins to increase. And as far as decreasing, the graph of the function is going down right up until -1. And -1 created a minimum because of the sign change. And there's the lowest point right there on the graph at x equal to -1. Alright, so next example is going to be one where you guys try it. So here's the little scenario, and here's the graph of g prime. So I'll give you a moment to pause it, copy g prime into your notes, and then there's only 2 parts to this one. You're going to first identify where the interval is decreasing, and then find the x values at which there's any relative extrema, and then state the type and justify your answer. This should be justify your answer, not our answer. Right. So you should copy this down, and I'll give you a moment to pause it, try these problems yourself. I'll go over the answer. I'll go over the answer now. So decreasing is whenever my derivative is negative, so it's negative between -2 and +2. I'm going to put it down as -2 and +2. You could have wrote your answer also like this. X is an element of -2 to +2. Both of these are equivalent. And it also is negative, the derivative is, from 5 to infinity. So I'm going to include comma from 5. X is bigger than 5, so less than infinity. Or you could have wrote it also as x is an element of 5 to infinity, like that. Alright, to justify, or for B, to find out where there's any relative extreme, I have to look for sign changes which occur at -2, at +2, and also at 5. So at x equal to -2, there's a positive to negative sign change. So this would be your relative maximum. And then to justify our answer, we have to state this type of sign change. So you would say that f prime, or sorry, g prime of x has a, I can just say a positive to negative sign change. Going along the line now, at x equal to +2, there's also a minimum, because it's a negative to positive sign change. And then I have to just state the type of sign change, which was g prime is going from negative to positive. And lastly, at 5, there is a positive to negative sign change, which would create a maximum. So x equal to 5, relative maximum. And then to justify your answer again, you state the type of sign change goes from a positive to negative. So to justify, you have to state the type of sign change that occurs. You could have either wrote it out in symbols like this, or you could have wrote it out in words, would have been fine. And then kind of just to confirm our answers, here's the graph of the function along with the derivative. You can see at -2, there's a maximum, so there's a little hilltop. At +2, there's a minimum. And you can see on the graph there's a kink on the graph of g, which makes the derivative not differentiable. That's why there's kind of a vertical line at 2. It's not defined at 2 because of the kink on the function. And then at 5, there was a maximum, this little hilltop. And that's it for this video.